He was the one who studied Pangea. He was the one who discovered continental drift. He was the one who studied plate boundaries. He was the one who made it possible for everyone to learn about magnetic reversal. He was the one who studied oceanography. His name? Alfred Wegener. Alfred Wegener noticed that the continents fit together in a map, and it sparked his interest in the topic. In 1910 to 1911, he found evidence of plant and animal fossils all over different continents,
which led him to presenting his ideas in a lecture in 1912 in Germany. In 1915, he published a book about his ideas as an extension to his lecture, which showed evidence about continental drift. He included the fact that many small freshwater reptiles couldn't travel over the Atlantic Ocean.
And he showed his travels in Greenland, in which he explored the maps and graphs that he made, and all the data about pressure that he recorded. This led his idea of Pangea, which answered many geological and biological questions about plate tectonics at the time.
Scientists finally understood how ring of fire and plate tectonics work, which led to many new ideas about the atmospheric pressure and continental drift.
Like certain other scientists before him, Wegener became impressed with the similarities in coastlines of eastern South America and western Africa, and speculated that those lands had been once joined together.
While at Marburg in the autumn of 1911, Wegener was browsing in the university library when he came across a scientific paper that listed the fossils of identical plants and animals found on the opposite sides of the Atlantic.
However, no traces of such bridges were found, nor was a convincing reason to advance them to sink if the material had been lighter than the crust of the ocean floor to begin with.
By 1910, he had noticed on a world map that the east coast of South Africa fits exactly against the west coast of Africa, as if they had once been joined.
After this, Wegener made his second trip to Greenland. When he was finished, he was drafted into the German army for World War I. Since he was wounded twice, he was put in the weather forecasting station. He looked further for evidence and found it. In 1915, he published The Origin of Continents and Oceans.
In 1919, Wegener was appointed the leader of the Department of Meteorology Research of the German Naval Observatory in Hamburg. This is why the Wegener family resettled to Hamburg.
Scientists believe that the Earth's magnetic system was created by slow movement in the Earth's liquid outer core caused by the rotation of the Earth. The generation of Earth's magnetic field is a continuous but variable process that causes change in not only intensity of the magnetic field, but also causes magnetic north pole to move as well as the reverse of Earth's entire magnetic field.
Lava, which hardens into rock, contains grains of iron oxides that point towards the magnetic poles as the rock solidifies. It is the most complete theory of global dynamics yet, and its roots lie in the work of Alfred Wegener. In 1906, he took a trip to Greenland, his first of 4 expeditions. He had meanwhile become interested in paleoclimatology, and in 1906 through 1908 he took part in an expedition to Greenland to study polar air circulation. While earning his PhD in astronomy, Wegener also took an interest in meteorology. Back in Germany in 1908, Wegener became an associate professor in meteorology at the University of Marburg.
The common simplified explanation for why tectonic plates are moving is that they're carried along on currents in the upper mantle, the slowly flowing layer of rock just below Earth's crust. Converging currents drive plates into each other, diverging currents pull them apart. This is mostly true. Hot mantle rock rises from the core and moves along under the crust until it grows cool and heavy and sinks back down again. Neither tectonic plates nor luggage can move faster than the belts they're riding on unless something else is helping to push or pull them along. And some of Earth's plates, it turns out, are pulling themselves. When an ocean plate collides with another ocean plate, or a plate bearing the thick crust of continental landmasses, the thinner of the two plates bends and slides under the other. As the edge of the sea floor sinks into the mantle, it pulls on the plate behind it, the same way a chain dangling further and further off a table will eventually start to slide.
They rejected Wegener's truly compelling evidence for continental drift. They also rejected work which today we recognize as the forerunner of the correct explanation of continental drift, plate tectonics. The idea that solid continents float on a fluid mantle. After this, Wegener made his second trip to Greenland. Porslut is German for poles light. Wegener proposed that there was a geological force which pushed the continents away from Earth's pole towards the equator.
Sometimes, when two tectonic plates move towards each other, one of them is forced downwards. This is called subduction. Yet sometimes when they push against each other, they are both crumpled. This is called uplift. You'll be surprised to learn that this is how the Himalayas were formed.
This was untrue. Geologists told him it was untrue. Unfortunately, they threw the baby out of the bathwater. They rejected Wegener's truly compelling evidence for continental drift. They also rejected work which today we recognize as a forerunner of the correct explanation of continental drift, plate tectonics, the idea that solid continents float on a fluid mantle. There, he turned first to physics and the optics of the atmosphere as well as the study of trombone, cyclones. Searching for evidence to further develop his theory of continental drift, Wegener came across a paleontological paper suggesting that a land bridge had once connected Africa with Brazil. In 1910 through 1911, he found evidence of plant and animal fossils over different continents, which led him to presenting his ideas in a lecture in 1912 in Germany. There, he quickly gained a reputation for giving lectures that made difficult topics easy for his students to understand. In 1910, he brought together the meteorological data he had collected in Greenland with his talent for explaining tough concepts simply and publishing his first book, Thermodynamics of the Atmosphere. Suddenly, on his last expedition to Greenland, he left to get some resources and died in the ice. His wife told him to keep his body there, which was where he wanted to be. Moreover, as Wegener had predicted, the movement is part of a grand-scale process that causes mountain building, earthquakes, volcanic eruptions, sea level fluctuations, and apparent polar wandering as it rearranges Earth's geography. Finally, in 1965, the research ship Eltonin took samples from the seafloor on both sides of a ridge in the eastern Pacific. One profile in particular, a sample called the Eltonin 19, caught everyone's attention. The magnetic recordings astounded Earth scientists. Tanya Atwater was beginning her long career in geology and remembers her amazement when she first saw the pattern created by the Eltonin 19. In his talk, Jim Hertzler put up the Eltonin 19 magnetic anatomy profile still, to this day, the clearest, most beautiful, and symmetrical profile in the world, and made the case for seafloor spreading. It was as if a bolt of lightning had struck me. My hair stood on end. In the beginning of the mid-1950s, a series of confirming discoveries in paleomagnetism and oceanography filled and finally convinced most scientists that continents do indeed move. Now, prediction of the location of the plates become trickier when looking beyond 100 million years into the future. Some simulations predict that in 100 million years, the Atlantic Ocean will begin to close as new subduction zones along the eastern coasts of North and South America begin to consume the sea floor that separates the western and eastern hemispheres. During this time, the Caribbean Sea will begin to close. India will plow through Eurasia on its way to the northern edges of the continent. In 150 million years, North and South America will be pulled into the current joint land masses of Eurasia and Africa. In 250 million years, a new Pangaea might be born as the continents once again fuse together in a single supercontinent before the inexorable tectonic forces split it into new continents as the cycle of creation and destruction continues.
What's up, my mammals? This is Sid the Sloth from the movie Ice Age, and we're about to do this new dance, the Continental Drift. It's time to get up on your feet. It's easy to do. Just follow me. Move it out. Do the Sid. Take it back and do the Sid.